The next thing we're going to look at is the ionic radius, and the ionic radius is when the atoms bond. So when they get to that status that is similar to a noble gas. All of the atoms want to be like a noble gas. They want to have their outer electron shell either completely empty, so if they're over here, they would lose electrons to get empty like the noble gas on the previous line, or if they're on the right side of the periodic table, they want to gain electrons to be like that noble gas at the end of the line. So our first column wants to lose one electron, so it's going to have a positive 1 charge. Well, if it loses an electron, then it's going to end up getting smaller. But the second column is going to lose 2 electrons, so that's going to get even smaller yet. The third column is going to lose 3 electrons, so it's going to be even smaller yet. And the fourth column is going to lose 4 electrons, so it's going to get even smaller yet. So the fourth column is going to be even smaller than that first column. So you're going to have a change in size going from smaller in that fourth column to getting a little larger, little larger, little larger. All of them are going to have the same number of electrons as the previous row's noble gas, but the size is going to increase going from that fourth column back to that first. Then when we look at the other side of the periodic table, our noble gases are going to stay consistent, so you're not going to be documenting anything for those. But the column right next to the noble gases, because they only need to gain 1 electron, and they're going to have a negative 1 charge, they're going to be smaller than the ones in the column next to them that are going to gain 2 electrons. They're gaining more stuff, so they're going to be bigger. So the trend for the ionic radius is going to be going from smaller to bigger, and then again from smaller to bigger. If you have any questions on this, let me know.